Welcome to this 20EC607L Internet of Things Laboratory. So today we are going to see the entire session of this lab equipment. So how many experiments in this Internet of Things laboratory? There will be having a 12 experiments in this laboratory. So the first one we are going to see in this session is simulation of your blinking LED and DC motor. So first experiments we are going to see that. So what is the main options? First we have to observe that text and then a coding, and then finally we are going to simulate that. Okay, so what is the experiments? Note it down that there is a 12 experiments. Simulation of blinking an LED and DC motor using Arduino. Second one, simulation of ultrasonic sensor interfacing with Arduino. Third one, IR sensor interfacing with Arduino. Fourth one, LDR sensor interfacing with Arduino. Fifth one, DHT11 interfacing with Arduino. Sixth one, soil moisture based automatic pump control with Arduino. Seventh, DC motor forward and reverse control using Arduino. Eighth, servo motor interfacing with Arduino. Ninth, PIR sensor interfacing with Node MCU. 10th, DHT11 sensor interfacing with Node MCU and Blink. 11th experiment, lamp control using Node MCU and Blink. 12th experiment, distance measurement using Node MCU and ThinkSpeak. So these 12 experiments we are going to see in this laboratory. So the first two experiments is a simulation. The other one we are going to use to simulate and the corresponding to your board. Okay. The first experiment we are going to see. First we need to go to your browser, Chrome browser, and then Google, and go to the Tinkercad website. Just click this Tinkercad, create 3D digital designs with online CAD. So click it. And then in the right side corner there will be login and sign up. You need to log in here. So next one, here you have this options, educators, students with class code, student accounts. You need to click this educators. Next, all must have this Gmail account, then only it will be linked and then redirect with the Tinkercad website. So you just click this sign in with Google. So I'm already having this account. It will be automatically redirect to your Tinkercad website. It takes a time. Okay, next, your website. Inside the website you have the options like this: home, class, designs, and then in the right side corner, so you have to click this icon, go to my design, that is a new design. You just click this and then automatically you have to create a circuits here. After clicking this, your schematic part will be displayed here. So this is a schematic part of this experiment. So inside your right side of your corner, you have a components. The basic components will be displayed here: resistor, LED, and then a DC motor. These and all will be used for the further experiments. So you have to click the Arduino now. It is automatically a pick and place the component only. So you all of them has to be easily do this particular experiment. So you have to click this blink. So just click it. You have to place in the schematic part. So what is the connection is going to be used here means, so basically this is a Arduino Uno board. So this part is going to be used this power side, that is 5 voltages or 3 voltages like that, and then this part is going to be used as a analog pin, and totally this 0 to 13 is a digital pin only. Okay, so this is the basic connections. Your cathode, that is you having a LED having a cathode and anode region. This cathode is connecting a negative region only, that is into the ground. So wherever the ground it is having means you just need to place there, and then anode region it is going to be connecting in that some digital pin. Here they are connecting into the 13th pin, so it is defaultly having a LED pin there. So why you are using this resistor means, so this board will be capable of that 5 voltages. This 5 voltages is directly is going to be connecting into that LED means it will be burst. So with the help of this resistor only, it will be automatically resist the component. Okay, so this is the explanation of this experiment. So you just to click this, you need to change your experiment here. So what is the experiment? Simulation of blinking LED is automatically changing here. So what is the aim of this experiment? To simulate the blinking and LED with Arduino using Tinkercad. So what are all the apparatus required? Apparatus required is your Tinkercad website, and then inside the Tinkercad you having a Arduino Uno board, and then LED resistor. That's all. So procedure, you have to use that. Go to the Tinkercad website and link with Gmail account, and then go to new design, and then click the create circuits, and then which experiments you are using, that means that blinking LED. Here we are seeing that a blinking LED, you just pick and place the necessary component for the given circuit diagram. So next one we are going to check a code here. So code, you inside the code you having a 3 options: blocks plus text. So you just click the text here. So this is the entire program of this experiment. So you having a 2 syntax here, that is void setup and then loop. Void setup is going to be used for a pin mode connection for a input and then output. So void loop is used for the entire operation of this program. So this is a pin mode connection. They have mentioned as a LED bulletin. So this bulletin is taken as a default for the 13th pin. So you don't need to connect a particular pin also. So instead of that, I just use that 13th also. It will be automatically function this program. I just erase this LED bulletin 13th pin. Okay, So and afterwards with the help of the 13 it is going to be used this entire program. You can also connect this entire connection also in a different digital pins also. So which pin you are going to connect, you have to give a correct pin connections here, then only it will be functioning here. Okay, so what is that? Your void setup is going to be used as a either in a pin mode connection input or output. So here the program you are using as a output connections only. Next, void loop. So digital write. So digital write, it is going to be used in this digital pin, so that only we are using as a digital write. See the this particular things and all as a case sensitive. So digital write, D is a small letter, W is a capital letter. So next one, this is a pin connection, and then with this one is a operation you are going to use for that. So how the program is executing means, so digital write you are using the for a digital pins 13th pin. So this particular operation is your LED is glowing for a particular seconds. Here I am mentioning as a 1 milliseconds. Okay, so there is a 1 seconds equal to. So this will be automatic. After a 1 second your LED will be glow, and then after a 1 second your LED will be off. So like that I have programmed here. So you just click this code, it will be automatically close that program, and then next one you are going to start that simulation. So your program is successfully has verified here. Okay, the next one you just go to that previous site. Why we are going to that means you have to again do that another one experiment for that. Again the same options you are going to see here. So now we are going to see that simulation for your DC motor. So it is also comes into your first experiment. So click the new design. Inside the new design you have to create a circuit. So you just type it DC motor. So this DC motor is comes as a different option. So you have to click a correct option means you have to click a Arduino here. So go to that and type it DC motor. So here there is a different options we are going to connecting in the DC motor. So this one is normally from the battery. So this one is normally from your breadboard. So you have to use the compulsory with your Arduino board only. So you just click this PMOS for the pick and place in the schematic diagram. So it will be the pages, it will be automatically connecting here. So you have to see the here clearly means just click that zoom out this entire page. So you can clearly see this entire program here, entire your circuit here. So you just place here. So the next thing you have to rename your experiment name here. So you have to rename this simulation of DC motor. So it automatically changes here. So now we are going to check this code. So go to the text, continue. Okay, here there is a program. Okay, so here there is a two global variable I have declared here in sensor value, int output value. Defaultly I have given as a 0 here. So as I told that previous classes itself, that is a void setup is for your pin mode connection. So pin mode connections, it is going to be used as a input or output for that. So here there is a two things we are using here, input and output. So your input is your potentiometer and then your output is connecting the your DC motor. Okay, so A0 is going to be used in that analog pin. So that is your potentiometer. So that only I am mentioning here A0, and then your output is connecting into that ninth pin. So here there is a aim to simulate that DC motor with Arduino. And then what are the components you are using as here means, first your Tinkercad website, next Arduino Uno component, and then DC motor, diode, NPN transistor, PMOS, and then your potentiometers, and then 9-volt battery. So these are the components you are going to use in this apparatus required. And then your procedure you have to write it down. Go to the Tinkercad and link with the Gmail account. And then second one, go to the new designs. So and click that your circuit, create that circuit there. So third one, what experiments you having this? In this experiment you having the simulation of DC motor means, pick the DC motor component and place in the schematic blocks. And then fourth one, so just having a proper connection and then clicking that your for your code and also your start simulation. Okay, so we have to check the code here. So code, so already I told that void setup for your input output, and then void loop is for your entire operation of this program. So sensor value, so sensor how it is going to be analyzed means with the help of that potentiometer. So it is connecting in that A0 means it is a analog read A0. So if it is you're connecting in the digital means digital read. So next output value, how it is going to be mapping means with the corresponding sensor value, how it is your value will be 0 to 1023, it will be going to be increasing that. So apart from that it is not going to be increasing. So with the corresponding final value 1023, it is you having a output value is 255 there. So and then you have to analog write ninth pin, and then your output value is comes up upon 255, or else within the 255 only your value will be displayed there. And then you have to print a sensor and then your output values in a serial monitor. Okay, here there is a serial monitor, you have to see that output here. Okay, so now all the connection is defaultly placed here. So now you are going to click that start simulation here. See here your out sensor value 511, it is equivalent to that your output value is 127. So 1023, I just clicking that 1023 here. So potential value here equivalent to your output value is 255. So your output is successfully verified here. So this is the output of this program. So and then your RPM is increasing here. So either I am increasing that value, your RPM also, your DC motor RPM also, it is functioning here. So either I am just decreasing the value means it is also your RPM will be decreasing here, and then your value sensor is a 246, equivalent to that your output value is 61. So that's all about your program. So now how you are using to place, it is automatically a pick and place only, we are just using here. So how we are using into that normal connection, that is we are going to see in this class also. So go to new design and then click that circuit. So it is, you are going to rename your experiment name simulation of blinking LED. It is changing here. So click the component Arduino. So your first option, it is normally connecting only your board and then your breadboard here. So you just place here for blinking LED. Here there is a no connection of this. You have to connect like this only by seeing that experiment. So next one, what is the component in this blinking LED? That is LED and then your resistor. So go to that basic and click that your resistor. I just place here, and then next one LED by clicking that. After that you just to place the component. How you are going to place the component? So just by clicking that, this is one is a cathode. So cathode is going to be connecting into the negative. So it is automatically connecting here defaultly. So otherwise you also going to be connecting that negative part and then your positive part, that is ground, and then your power. So here you are seeing that is a ground part is connecting into that either in this side and also your this side, and then your power part is going to be connecting in that either 5 volt or else 3 volt like that. So now you are going to connecting the component. So clicking this, you have to rotate. It is automatically place that which direction you want. So in the anode, I just going to be placed here. From that finish this. So why I am connecting here means this will be a parallel connection. So one end of the resistor is here means you need not going to be connecting here. You just going to be use this connections only, or either this particular point. So if you are connecting here means it will not be functioning there. Okay. So the another end I just taking that directly, I am going to be given as a digital pin here. So where I am connecting that 11th pin, I just used to connecting here. So this is a digital pin. So click that code, go to text. You just see this experiment. You having default that your program. Here there is a LED bulletin. You have to given as your pin connection here. Which pin I have connected here? 11th pin. And then you have to replace wherever that LED bulletin, you have to connecting that 11th pin here. So this is that you are going to changing here. So now close the code and then start a simulation here. So your output is successfully verified here. So after clicking that stop, I just taken this resistor. it is directly going to be connecting that your 11th pin. You just click it and then delete, click the delete option here. It will be automatically deleted. So I directly connecting this 11th pin here. So how this action is going to be performed, just see that start simulation. So you just see here indication of this. You just see here what is that happening means it directly passes that 5 voltages through this LED means. So here it will be a indication of that you need not connect it like this. You have to give some component like resistor like that. Okay, so for that indications only I'm just connecting this resistor here. So you just check it out like this also. Okay, this is the entire things you have to connected this. So based on this all the simulation experiments you have connected like this. So like many projects, and then also whatever experiments you need to connect it the like this you have to expose like that. So thank you.